Okay? Okay. So, introduction. So this is mostly just going to be, I'm just going to introduce some terms and ideas, a lot of which we've already encountered with the survey. And actually, let me say something about that survey. There are so many different things in that survey that we could talk about. We'll probably come back and reference that survey for the next month. Say an example, and we can find an example in the survey of all the things we bring up. Okay, so first of all, so the technical definition of data is, we call it information. The definition of data is observations or measurements. Okay, so for example, each piece of information comes from me, quote unquote, observing or measuring your answer. Now notice that another way to get data is not to ask someone a question in a survey, but simply to watch their behavior. For example, when you do an experiment, you want to say, let's see, if I give someone a certain amount of caffeine, does it make them stay up later, for example? They're not going to tell. You could either say, well, how late did you stay up that night? Till 2 in the morning. Or you could watch them. For example, if you're in a more controlled experimental setting. So for that reason, you could think of gathering data through observing someone. So statistics is the study of planning and doing a survey or experiment. Okay. So when we do a study, we have to ask ourselves, who are we studying? So in the example of the survey from the beginning of class, who was I studying? Who's us? Which students? All BMCC students? I was studying my Math 150 students. So could I reasonably say that I was studying all BMCC students? No? Why not?
Because it's a percentage that could be applied to a greater number.
Right. So could I say, in order to understand the opinions and feelings of all BMCC students, I asked my students. Is that a reasonable thing to do? Why is that a reasonable thing to do? Okay. All right. Yeah. No. Okay. Other thoughts?
Well,
Yeah.
statistics is kind of a general class that most people have to take, so you would be covering a large percentage of the students.
Okay. Does everyone who goes to this school wind up taking statistics? No. So is it possible that you guys, as students taking statistics, have certain qualities that are not true of BMCC students in general? Not just possible, I would argue likely. Okay. You made certain decisions to be in this class, and that makes you distinct from the rest of the population. I could very easily divide the BMCC population into two groups. Students who have taken Math 150 and students that have not. And I bet that you could find that those two populations are not the same. Okay. For example, question number, I think it was question number 4 or 5, are you comfortable taking a math class? I bet that I'm going to get a higher count of yeses from my Math 150 students than BMCC students in general. Or maybe not. Maybe you guys want to do that study. Okay. So, this brings up an important distinction that I want to talk about now. We're also going to get to this. So we also started talking about whether or not you guys are representative of all BMCC students. We're going to talk about that as well. First, let's define some things. Population represents everybody you are studying. Okay. Now, when I took that survey, who was I studying? I was studying my students. Okay, so the population would be my Math 150 students, 9 a.m. class. Okay. Now, the sample represents some of the people from the population, and those are the ones that you observe or that you get data from. Now in this case, my entire population was only 25 people. So was it possible for me to ask everybody in my population to get my data? Yes. What if I really wanted to study all BMCC students, which is there are about 20,000 students? Is it likely that I would be able to go around and ask every single BMCC student? No, absolutely not. So what I would have to do is, instead of asking 20,000, I would have to ask, I don't know, say 100. And that 100 would represent my sample. So that's the distinction. The population represents everyone you were studying. But the sample are the actual people that you get the information from, that you get your data from. Like for example, when you see those polls that say 62% of all Americans, support such and such, is it likely that they really went around and asked all 300 million Americans? No. What did they do? They asked a certain amount of Americans. They asked, say, 2,000 Americans. They got, out of those 2,000 Americans, 62% said yes. So they said, according to our study. But they didn't ask the entire population, they only asked a sample. Now, it is possible to ask the entire population. But it's hard. What makes it hard? Oh, okay. Well, fair enough. So, okay, let's say all adults. I asked the 4-month-old, but he didn't say anything. He just looked at me. No, that's not what I mean. So let's fine. Let's make it all U.S. adults. Okay. What would make it hard to ask every single U.S. adult whatever question you want?
Keeping track of who you ask?
Well, yeah, but let's presume that you actually have software in a database and all that. Okay. How many U.S. adults are there? I'm going to go with something about 200 million. So what would be the hard part about doing that? Time! Absolutely. This would take a very, very, very long time. Okay? And presumably you wouldn't do it all by yourself, so you'd have to do what? Hire people. This requires money. Time, money, resources, all these things make it hard. Okay? So when you do in fact ask everybody from the entire population, it's called a census. But this is for a big population like the United States population or U.S. citizens, this is very hard to do. And in fact, there's really only one organization that's capable of doing it. It's called the U.S. government. And you guys, census, that word should sound familiar. U.S. Census, conducted by the Census Bureau. Now, a census is so hard to do that, you know how often they do them? Once every 10 years. It takes the entire federal government 10 years to do all these things. Well, it doesn't take them 10 years, but they do it every 10. It takes them a couple years. Gather the data, process it, all these things. Okay. And even the government misses a couple people, but we're going to talk about those problems later. Okay. So I'm going to define as a study when you take a sample and you ask or collect data from those people. So, types of data. So we talked about this a little bit already. If your data comes in as words or numbers, words, that's called qualitative data. And the reason you can think of that is that words describe a certain quality. Numbers are called quantitative data because numbers describe a quantity. There you go. That's how to remember that. Okay. So for example, when you say my major is liberal arts, that's qualitative data. When you say the number of classes I've taken is 3, that's quantitative data. All right. Now, among quantitative data, there are 2 types of data. So, number of classes I've taken. Could someone say I've taken 2.4 classes? No, it doesn't make any sense. Okay. But if I said, what temperature is it outside? Could I say, really I could say, gosh, it's cold. But I could also say it's 31.74 degrees. Could I say that? Okay. So clearly these are two different kinds of quantitative data. So the one where there's only certain possible answers, that's called discrete data. Discrete quantitative data. Now, when every value is possible, that's called continuous data. So in this example, temperature would be continuous quantitative data, and number of classes, 1, 2, 3, that's discrete quantitative data. All right. All right. Just a little, all right. Okay. So suppose you go to an ATM and an ATM only gives out 20s. Exactly how much money is it possible to get from that ATM? Okay. Suppose you have $1 million. All right, go. Okay. What's possible? It's got to be a multiple of 20. I was thinking someone would say something like you get $20, $40, $60. Okay. Can I get $27.50 from the ATM? No. Okay. So what kind of data is this? Right. It's discrete and it's not continuous. What kind of data? Quantitative. You skipped over that step, but you should say it's quantitative and it's discrete. Okay. So a quick note, something that I mentioned earlier, but I want to make sure it's clear. Okay. Writing these things down. In question number 1, what kind of data do we have? Is it quantitative or qualitative? Where is it numbers? Okay. 4 and 21 is not your data. In question number 1, what's your data? Yes, no. Exactly. Your data are the yeses and nos. Your data is qualitative. Yes is 4 and no is 21. That's a presentation of your data. Notice that even if you've got words as your data, you can always count up the number of words. That does not make your data quantitative. It's qualitative. You dig? Yep.
Can you give another example of continuous quantitative data?
Sure. Let's see. How much, let's see. When you buy a can of soda, how much soda is actually in the can? Okay. Could be 16 ounces, or it could be 15.7 ounces. Make sense? Okay. The truth is that most examples that we're going to do have to do with counting, so they'll be discrete. 1, 2, 3, 4, 5. But there are examples where it's continuous.
Is money exchange, like, say, $1 is 6 money? Is that a quantitative? No.
Is money continuous or discrete? That's a good question.
You can say $1 is worth, for example, 37 points.
Right. Technically, it's discrete because I would say generally we don't say 37.5 cents. Yeah. So you have to money. You can only count money to the nearest penny. So it's discrete. We've broken it up quite a lot, but it's still discrete. Yeah. That's a tricky question though. Yeah. Okay. Okay. And I want to also make another comment about one quick thing. So actually, oh, you had brought this up earlier. You said certain kinds of questions you can answer it. You said you answer either yes or no or with numbers. So depending upon how you write your question, you can either design your question so that you get qualitative answers or quantitative answers. Consider the question from the survey, do you like ice cream, yes or no? How could we ask this question in a slightly different way so we're asking the same question, but we get numbers for an answer? That's not the same question though. Related question, but it's not giving us the same information.
Do you have so many people like that?
How many people like ice cream?
Oh, how many people I
Here.
But in effect what you're doing is asking yes or no. Do you like ice cream, yes or no? It's really the same thing. And then you're just counting up the yeses and nos. So I'll give you the answer to show you what I mean. How much do you like ice cream on a scale of 1 to 5? Notice how it's the exact same, it's really the exact same information, but instead of getting a yes-no answer, you're getting a from 1 to 5 answer. And again, remember I mentioned before that there are advantages to having numbered data. You can do further analysis on it. Okay. And that's the end of section 1.1. So if you register, you can certainly feel free to go ahead and do that homework for next time, or we can just wait for Wednesday. All right, thank you guys. See you Wednesday.
I have a question.